Hello, and welcome to the fundamental theorem of algebra. The fundamental theorem of algebra states that a polynomial f of x of degree n, with n greater than or equal to 1, has at least one complex zero. And that doesn't seem like it should be a fundamental theorem, but that was huge when they discovered that this is true. In fact, the number of zeros theorem tells us that a polynomial of degree n, with n greater than or equal to 1, has at most n distinct zeros, So we know we have at least one complex and at most n that are different. We could have some repeats and we'll have multiplicity. So if I want to find the complete factored form of a third degree polynomial with real coefficients, where a sub n equals 5, so I have f of x, my leading coefficient is 5, I have a 0 of 2, so I have a factor of x minus 2. A 0 of I, so I'll have a factor of x minus I. A 0 of x equals negative I, so a factor of x plus I. And then we can expand this to write it in standard form. So I'm going to multiply two at a time. I'm going to multiply these two. And I'll get 5x minus 10. I'm going to multiply these two. I'll get x times x is x squared. X times I and negative I times x, they're going to cancel out. Negative times a positive is negative. I squared is the same as 1. All right, negative 1, actually. I squared is negative 1, so if I subtract a negative 1. And now we will distribute once again using the FOIL process, if you're familiar with that, or just distribution. We'll have 5x cubed plus 5x minus 10x squared minus 10, and most times we will choose to write these in descending order. So we have standard form, nice little decreasing order idea here. And there we have our third degree polynomial, leading coefficient of 5 with the zeros 2i and negative I. All right, let's find all the complex zeros of x cubed plus 2x squared plus 16x plus 32, and we're going to write the complete factored form of f of x. So first thing I'm going to do is I'm going to try Descartes' rule of signs. So for f of x, my signs are all positive, no change. No positive zeros. All right, that's awesome. So I don't have to try 1 or anything like that. I know it's going to be negative. If I try f of negative x, I'll have a negative and then a positive and then a negative and then a positive, right? Because every odd power will become a negative. Even powers and constant terms will stay positive. So that's 1, 2, 3. So 3 or 1 negative real zeros. So I know I'm only looking for negative real zeros, and there might be complex zeros as well. So my next step is my rational zeros theorem. If you need to, review the real zeros of polynomial functions video that was, I believe, released right before this one. Rational zeros are of the form p over q. The only factors of 32 are the powers of 2. And the only factors of 1 is 1. And I know I'm only going to use the negative values, so I'm only going to try negative 1, negative 2, negative 4, negative 8, negative 16, and negative 32. All right, because Descartes said you're not going to have any positive ones. Don't waste your time. Now, to put in negative 1, I kind of look at the coefficients and I see that they're not going to work out. There's not enough symmetry and not enough evenness or equalness in the coefficients, and that's just through experience. In order to conserve time, I am going to start with negative 2. Negative 2, my coefficients are 1, 2, 16, and 32. Drop the 1, multiply to go up and over, add straight down. Multiply to go up and over, add straight down. Multiply to go up and over, add straight down. 0 remainder, so negative 2 is a 0. So this is our remainder. As long as the remainder is 0, we know that x equals -2 is a 0. And I'm going to write here 3x equals, because I know a third degree polynomial can have at most 3 complex zeros. Now, this was an x cubed, so this would become an x squared. So what we have as a quotient is x squared plus 16. Our divisor, since I used -2 as a 0, that's x plus 2 as a factor. And then I can factor this, or can I? It's the sum of squares. And the sum of squares doesn't have a perfect formula for factoring, but remember I'm trying to find zeros. So if x squared plus 16 equals 0, then x squared equals a -16, and x equals plus or minus square root of -16, which is a plus or minus 4i. So I have positive 4i, I have negative 4i. I know my zeros. If I know my zeros, I can go back and look at the instructions, find all complex zeros. Done. Write the complete factored form of f of x. So my complete factored form will be f of x equals x plus 2 times x minus 4i times x plus 4i. Both parts of the problem complete. All right, so Descartes' rule of signs and the rational zeros test really help us to narrow this down in the synthetic division. It's all coming together here in college algebra. All right, conjugate zeros theorem. Notice that when I had I had negative I. When I have 4i, I also have negative 4i. And that's not a coincidence. These are not just perfect little problems. In fact, the conjugate zeros theorem tells us that if a polynomial f of x has only real coefficients, so real numbers as coefficients, if a plus bi is a 0 of f of x, then the conjugate a minus bi is also a 0 of f of x. All right, always they come in pairs. So find the complete factored form of a fourth degree polynomial with real coefficients f of x, where the leading coefficient is 1/2. I have zeros of negative I. So I know x equals positive I must be a 0. And I have a 0 of 2i, so I know that x equals negative 2i, the conjugate must be a 0. We turn these into factors to get x plus I times x minus I times x minus 2i times x plus 2i. Find the complete factored form. Done. Every time before you enter an answer in your homework system, or even leave it on paper if that's the way you're going, make sure to read the instructions. Make sure, are you looking for the zeros or are you looking for the factored form? Or do you need to write the polynomial in standard form? There's 3 different ways we could go with this type of problem. All right, so let's find the zeros given 1. If I know that k equals 3i is a 0, then I know also that k equals negative 3i is a 0. And I could do synthetic division using the 3 i's, but instead what I will do is I'm going to revert to long division of polynomials. Check this out. My zeros turned into factors. X times x is x squared. Positive 3ix and a negative 3ix cancel out. So I'll have a negative. 3 times 3 is 9. I squared is the same as negative 1. So I'm going to take x squared plus 9 and divide it in to 2x to the 4th minus x cubed plus 19x squared minus 9x plus 9. Okay, synthetic division works for linear factors. Here I have a quadratic factor, so I'm going to use long division. What do I multiply x squared by to get 2x to the 4th? I'm going to multiply by 2x squared. So let's do that. Make sure you line everything up, the x squareds over the x squareds. 2x squared times 9 is 18x squared. Draw the line. Don't forget the minus sign. 2x to the fourth minus 2x to the fourth cancels out. Drop down the minus x cubed. 19x squared minus 18x squared is a positive x squared. And let's bring down the minus 9x. Play the game again. What do I multiply x squared by to get a negative x cubed? That's a negative x, right? Negative 1x. So a negative x times x squared is a negative x cubed. Negative x times 9 is a negative 9x. Draw the line, minus sign. Negative x cubed plus x cubed cancels out. X squared drops down. Negative 9x minus a negative 9x, so that's a negative 9x plus 9x. They cancel. And we drop down our plus 9. One more time, since x squared and x squared, we know we still can divide a little bit. What do I multiply x squared by to get x squared? And it is a 1. When I multiply x squared plus 9, draw the line, minus sign, remainder of 0. And I knew that. Because we had zeros, I knew my remainder was going to be 0. But I now have my quotient is 2x squared minus x plus 1. And as I try to factor this, I always try to factor first. This will be 2x times something and x times something. To get the 1, it has to be 1 and 1. To get a positive 1, they have to be the same sign. But this tells me they should be negative, but that doesn't work out. We have a negative 2x and a negative 1x. That's a negative 3x. So I'm going to use yellow here to indicate that doesn't work out. I like yellow for crossing things out because I can still see through it. So instead I'll use the quadratic formula, set this quotient equal to 0, and I will find x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is 1 plus or minus. That's 1 minus 8. So that's a negative 7 all over 4. And the square root of a negative gives me an I square root of 7 all over 4. So my zeros are the 3i and negative 3i. And then these two super ugly complex numbers down here. We found all the zeros, 4th degree polynomial, 1, 2. 1 is positive, 1 is negative, that's 3 and 4. All right. Now all of this is leading up to solving polynomial equations. We want to find all complex solutions. Okay, so let's do this in an organized manner. The first step, we're going to always, in order to solve polynomials, we're going to set the polynomial equal to 0. So when I move my terms to the left, I'll have a minus 2x squared, a plus 7x, and a minus 14 set equal to 0. Second step, I'm going to look at Descartes. Now the changes in positive, we'll have a positive to a negative, so that's 1, 2, 3. And we'll have 3 or 1 positive real zeros. When I change it to a negative, let's see, negative x cubed minus 2x squared minus 7x minus 14 equals 0. Right, if I replace x by a negative x, the odd powers change signs. The even powers and constant terms do not. Notice there is no change. 0 possible negative real zeros. Okay. And then I'm going to use the rational zeros theorem. So the rational zeros theorem says all my rational zeros of the form p over q will have factors of the constant term divided by factors of the leading term, 1. And I know I'm only going to check positive values and not negative values. So I'm not even going to put a plus or minus. I'm only looking at positive values. And we're going to start trying 1. If I put 1 in, think about it. When you're evaluating at 1, that's 1 minus 2 is negative 1. Plus 7 is 6. It's not 0. All right, so let's try 2. Step 4, start dividing. So 2, let's put it in. We'll have 1x cubed minus 2x squared, 7x, and a negative 14. A lot of times when when 7 times 2 is 14, right? A lot of times that's going to work out for us. Drop the 1, multiply to go up and over, add straight down. Multiply to go up and over, add straight down. Multiply to go up and over, add straight down. Because the remainder equals 0, I know x equals 2 is a 0. And further, I know that I now have x minus 2, right? The 0 turns into the factor. This was x cubed, so this is x squared. I'll have this polynomial on the left, x cubed minus 2x squared plus 7x minus 14, now factored as x minus 2 times x squared plus 7. In order to find, I'm going to use the zero factor property now. I know the 0, x equals 2. I'll look at x squared plus 7 equals 0. X squared equals negative 7. So x equals plus or minus I square root of 7. And we have all complex solutions, because real numbers are also contained in the complex numbers. Conjugate pair and a real number 0. We had one positive real 0 and the other 2 were complex. All right, let's do one more. This video is getting a little long, but some of these things just require time. So my first step, I'm going to set it equal to the 0, and I'm going to write it in decreasing order. So I'm going to make sure I put that x cubed inside, in between, right? Make them in order. Now, before I do anything else, I see that factoring, right? Don't forget our basics of factoring. I could factor out an x squared. Let it be easy, right? Start with the easiest part. Now, what I'm looking at is x squared equals 0, or x squared minus x plus 4 equals 0. X equals 0, and I'm going to put here multiplicity 2, so I know that the graph just touches at x equals 0 and then bounces off again. To find this 0, that doesn't look like anything I can factor, so I'll use the quadratic formula. Negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. That's 1 plus or minus the square root of 1 minus 16 is a negative 15 over 2. 1 plus or minus I square root of 15 all over 2. So I only have 3 zeros because one of them happens twice. So x equals 0 will happen twice. There we go. That's finding complex zeros using the fundamental theorem of algebra. That's all for this video. Thanks for listening.